The Pinecone Vector Query component is used to ingest text search strings and return text associated with similar vectors in your Pinecone vector database. This is an important step in retrieval augmented generation to add context to your generative AI prompts. In this example, we'll use this component as part of a pipeline where we'll answer customer questions related to data productivity cloud tasks and components. Our Pinecone vector database has been populated with our documentation to help answer these questions. So we'll use the Pinecone Vector Query component to retrieve customer questions from a table, then use an OpenAI text embedding model to generate embeddings for these questions. The component then performs a nearest neighbour search on Pinecone to find similar queries in the index, finally returning examples from our documentation, which will then be written to a new table. Our example documentation is stored as vectors within our Pinecone project in an index and a namespace. Now we'll use the Pinecone Vector Query component in a pipeline. After you've added the component to an orchestration pipeline, we'll need to set up the component, so let's go to the component properties. Under the source section, we need to define the table which includes the customer questions we want answering. In our example, this is a table called Component Queries. Here you can see the table with rows of customer questions. In the properties, select the column that just contains the questions. In this case, that column is called Query. Next, we need to set up the component so it will take these questions and send them to the Embeddings API. This is where the search strings will be converted into embeddings. Under the Embeddings API section, select the provider, in this case OpenAI, and then your API key for this account. Then we need to select an embedding model. In this example, text embedding ADA002. You must use the same embedding model for the search string as the one used to generate the vectors for the documents stored in Pinecone. So if we switch over to Pinecone for a minute, here we can see the embedding model that we used in the metadata. So next we need to connect to Pinecone. Enter the credentials for your account in the Connect section of the properties. We'll also need the Pinecone project, index, and namespace. In this example, the namespace is called Demo Component Docs. If you leave the namespace blank, then a search will be carried out on all the namespaces in your selected index. Using the top K property is where you define the number of closest matches we want our query to return. In this example, we'll select 2. Now that we have our closest matching vectors, we need to identify where the raw text data associated with these vectors is, so it can be returned by the component. In the Configure section, under Data Lookup Strategy, there are 2 options for this. Either raw data in metadata, which means your raw data is stored in key value pairs in the Pinecone vector metadata, or table details in metadata, which means instead there are source table details stored in the Pinecone metadata. Using this option reveals additional properties with a one-to-one mapping of the metadata from our Pinecone vectors. And for this example, we'll use table details in metadata, where if we look again in Pinecone, we can see the database, schema, and table names defined in the metadata. And then we need to enter these details in the component properties. Now we've matched our raw text data, we can output this to a new table using the destination properties. And we'll call our table Component Queries RAG Output. Once you've defined the output table, the pipeline is ready to validate and run. And once this is run, you can see our data, which includes the primary key and our original search string and the raw text, which matched our search string. Okay, now we've got the data we wanted out of Pinecone, we can push this data through an OpenAI prompt component to add context and return formatted results which can be used to answer customer queries. In this example, the context we're providing is you are a technical advisor answering support queries related to Matillion components. You'll be provided with the user query and some documentation retrieved by a vector search, which may be relevant to the query. And you will answer the query as if you are responding to the customer directly via email. So once that's validated, running the pipeline will output these responses to a table, which we've defined in the destination section. And now we've run the pipeline, looking at the data in our table, we can see answers to our questions using the documentation provided through our Pinecone Vector Database Query component, in combination with the context and format provided using ChatGPT in the OpenAI prompt component. One of the key benefits of using this component is you can search another namespace, index, or project to collect data relevant to the task you are asking the large language model to undertake. So in this example, say you wanted to use knowledge base articles to complement your documentation data. To do this, add a second Pinecone Vector Query component to the canvas, selecting a different namespace in the Connect section. Then, if you join this data together before pushing it to the OpenAI component, then you can query both namespaces at the same time. For more Data Productivity Cloud videos, please subscribe to the channel. And to get started with Matillion, visit matillion.com.